To fill the score of the rest, we have to consider the scoring function here. In the scoring function, you see that they have three different values: value 1, value 2, and value 3. We have to choose the maximum of the three values which come from three directions. For the first direction is the diagonal direction, and the second one is from the top cell, and the last one is from the left cell. So we have diagonal, top cell, and the left cell. Okay, so this is our target cell we were working on. We have, like I said, we have three directions, right? We have diagonal, which come from 0 here. We have the top cell, which come from -1. We have the left cell, -1 here. So we have three directions. Okay. For the diagonal line, the value that we can put, we have to consider between two nucleotides from first sequence and second sequence, which is G and A. You can see that G and A is mismatched, right? So we will put the score -1 here. And for the score of the top cell and the score from the left cell, we have to add by the gap value. We will perform the addition while using gap value -1. So -1 is -2. -1 is -2. Okay, so we have the score from three directions, and we have to select the maximum value. You can see that the -1 score is the maximum value. So I will put the final score in this cell. Sorry, -1, right? -1. And the -1 come from the diagonal line. So I will put the arrow from diagonal cell like this. Okay, let's move on to the next cell. We have to consider the value from diagonal, top cell, and left cell, three directions. Okay, from top cell and left cell, we have to add the score in the top cell and in the left cell with gap value. Gap value -1. So from score from top cell, -2 -1 will be -3. -1 will be -2. And you can see here, from the diagonal, we have to consider the nucleotide sequence. G and C is mismatched, right? So we have to add -1 plus -1 mismatch will be -2. So you can see that the maximum value is -2 that come from diagonal cell and from the left cell. So I will put the final score -2 and remove -3 out of the way. So I will leave the arrow from diagonal and left cell. Alright, this is the final score. For the next cell, we have to consider three directions. From the diagonal one, we have to consider the nucleotide sequence G and G. G and G is the same, so we will use the match score +1. -2 plus 1 will be -1. The cell from the top and from the left, we have to add with the gap value. So -3 plus -1 will be -4. -2 plus -1 will be -1. So you can see that the -1 score is the maximum value here. I will put the final score -1 here. And I will remove the arrow and score from the top cell because it gives the lower value. Okay? From this cell, we have to consider the value from 3 directions. Let's look at the diagonal one. We have to consider the nucleotide sequence, which is A and A, so it's matched. -1 plus 1 will be 0. From the score from the top cell and left cell, we have to add with gap penalty score -1. -1, -1, -2. -2, -1, -3. So the maximum value is 0. I will put 0 here. And remove the arrow and score from other directions. And I will go on for the next cell. From the left, from diagonal, from the top. Okay? From diagonal, we have A and C, which is mismatch. So -1 plus mismatch score, -1 will be -2. -2. From this one, from the top cell and left cell, we have to add with gap score -1, -2, -1, -3, 0, -1, -1. So the maximum value is -1. So I will put -1 here. And I will remove the score and the arrow from other directions. From this cell, from the left cell, diagonal cell, and from the top. Diagonal cell, I have A and G, which is mismatch. So I will add -2 with -1 mismatch score. So I will get -3. From the top cell and left cell, I have to add with gap score -1. So -1, -1, -2, -1, -1, -2. So the maximum is -2 from 2 directions. From the left and from the top. Okay. And this one, from left, from diagonal, from the top. From the diagonal one, I have C and A. So C and A is mismatched. So -2, -1, -3. Right. From the top cell and from the left cell, add with gap score. 0, -1, -1. -3, -1, -4. So the maximum value is -1 from the top cell. So I will put the score -1 and the arrow from the top cell. Next cell, the score from the left, from diagonal, and from the top. Let's look at the diagonal one. We have C and C, which is match score. So 0 plus match score 1 will be 1. From the top and from the left, we add with gap score -1, -1, -1, -2, minus 1, minus 1, minus 2. So the maximum score here is 1 from the diagonal cell. I will remove the score and arrow from all the directions. Okay, we come to the last cell. So consider score from the left, from diagonal, and from the top. So diagonal first, we have C and G, which is mismatch. So minus 1 plus mismatch score minus 1 will be minus 2. From the top cell and left cell, we have to add with gap penalty score minus 1. Minus 2 plus minus 1 will be minus 3. 1 minus 1 will become 0. So the maximum value here is 0. Okay, so 0 comes from left cell, so I will put this 0 score in the last cell. So you can see the path of the arrow in different way. So let's consider here. From the last row, we see that the 1 score is the maximum value, so I will highlight it here. The 1 score come from which cell? From the arrow. From the arrow, it come from diagonal 1. So we will highlight the diagonal arrow and the 0 cell. From the 0 cell, is come from diagonal value, right, which is minus 1 score, and minus 1 score come from the 0 value of the first cell. You see, the way that I highlight from the maximum value and back to the arrow and back to the cell that the arrow come from is called tracing back, or trace backing in step 3. So this is the way that we can identify the optimal alignment. Okay, so the path that I highlight in the yellow color is called the most optimal alignment. Okay, so we can write the sequence 1 and we can write the sequence 2 here. So we align from the last sequence. You can see that C and C is matched from sequence 1 and 2, right? And when we go back here diagonally, you can see A and A. So I write A and A here. Okay, and here you can see that the sequence 1 has the G, so I will put G on sequence 1, and in sequence 2 they have nothing, so I will put gap here in sequence 2, and sequence 2 you see A, C, G, so I will put G here. Okay, so this is the most optimal alignment that we get from the sequence alignment using Needleman-Wunsch algorithm. This is how the dynamic programming using Needleman-Wunsch algorithm works. I think you can understand more. And one thing I would like to point out is that if you found the straight line, you see 0 and minus 1, you can draw the straight line here. And if the straight line in that line here perpendicular or to the to which sequence, so here the dashed line is perpendicular to sequence 2, it means that we have to add gap on that sequence. Okay, this is the first example of using Needleman-Wunsch algorithm to find the optimal sequence alignment. If you have any question, you can ask me in line or leaving in the comment, so I will give you an answer. Thank you very much for your attention.